Welcome, everyone. I'm excited to kick off today's presentation with the topic of triangles and its properties. On this first slide, you'll see the title clearly displayed. We'll be exploring the fascinating world of triangles, their characteristics, and what makes them so important in geometry. Over the next few slides, I'll guide you through key concepts, properties, and perhaps some interesting facts. So, let's get started and dive into the fundamentals of triangles. Let's take a quick look at the contents of today's presentation. We'll start with the introduction, where we'll set the stage for our exploration of triangles. Then, we'll move on to the different types of triangles based on their angles, which will help us understand their properties better. Next, we'll delve into the Pythagoras theorem, a fundamental concept that relates to right-angled triangles. Following that, we'll learn how to calculate the area of a triangle, a useful skill in many real-world situations. After that, we'll examine the types of triangles based on their sides, which complements what we've learned about angles. Then, we'll explore some key properties of triangles that are essential for understanding their behavior. Next up is the concept of congruence of triangles, which helps us determine when two triangles are essentially the same. Finally, we'll wrap up the presentation with a summary and some concluding remarks. Throughout, we'll see how all these pieces connect to give us a comprehensive understanding of triangles. Let's start by understanding what a polygon is. A polygon is essentially a simple closed curve, which means it's made up of straight line segments connected end to end, forming a shape with no gaps or overlaps. Among all polygons, the triangle is the simplest one because it has the least number of sides, just 3. Now, focusing on triangles, they are plane figures formed by 3 non-parallel line segments. These segments connect to create a 3-sided shape. Triangles are fundamental in geometry because they serve as the building blocks for more complex shapes. Moving on to the elements of a triangle, we have 3 sides labeled OB, BC, and AC. In addition, there are angles opposite these sides, which we denote as angle A, angle B, and angle C. These angles are also called the parts or elements of the triangle, and understanding them is crucial because they help us analyze the properties and relationships within the triangle. These elements, sides, and angles are the foundation for many geometric concepts and theorems we'll explore later in the presentation. Recognizing how they connect and interact is key to mastering triangle geometry as a whole. Let's talk about the different types of triangles based on their sides. First up is the equilateral triangle. This is a special kind of triangle where all 3 sides are exactly the same length. Because all sides are equal, the angles inside are also equal, each measuring 60 degrees. This symmetry makes the equilateral triangle quite unique and easy to recognize. Next, we have isosceles triangles. These triangles have at least 2 sides that are the same length. The 2 equal sides are called legs, and the angle between them is called the vertex angle. The other 2 angles, opposite the unequal sides, are equal as well. Isosceles triangles are interesting because they balance symmetry with some variation. Finally, there are scalene triangles. These are triangles where no sides are equal. Every side is different in length, and consequently, all 3 angles are different too. Scalene triangles show us the full diversity that triangles can have. No sides or angles are the same. Connecting this to our overall theme, understanding these different types helps us classify triangles clearly, which is essential for solving geometric problems and understanding their properties more deeply. Now, let's explore the different types of triangles based on their angles. First up are acute angled triangles. These triangles have 3 acute angles, meaning each of their angles is less than 90 degrees. It's a good way to remember that all the angles are sharp and less than a right angle. Next, we have right triangles. A right triangle is one that has exactly 1 right angle, which is precisely 90 degrees. I'll highlight the right angle with this box so you can easily identify it. These triangles are really important because they follow the Pythagorean theorem, which is fundamental in geometry. Finally, we encounter obtuse angled triangles. These triangles contain 1 obtuse angle, which is greater than 90 degrees, but less than 180 degrees. This makes the triangle look a bit stretched out on one side. Understanding these types helps us classify triangles based on their angles, which is essential for solving many geometric problems and for connecting the different properties of triangles to the overall theme of shape and measurement. Let's talk about the properties of triangles, starting with the angle sum property. This is a fundamental concept that helps us understand how triangles work. Essentially, the sum of the measures of all three angles in a triangle always adds up to 180 degrees. So, if you know two angles, you can always find the third by subtracting their sum from 180. We can write this as MA plus MB plus MC equals 180 degrees. This property is key because it connects to many other concepts in geometry and helps us solve for unknown angles in various triangle problems. Remember, no matter what kind of triangle you're dealing with, acute, right, or obtuse, the total of its interior angles will always be 180 degrees. This is a great starting point for understanding more complex properties and theorems related to triangles. Now, let's take a look at the exterior angle property of a triangle. This is a really useful concept that helps us understand the relationship between exterior angles and the interior angles of a triangle. Essentially, the measure of each exterior angle, like angle 1 here, is equal to the sum of the measures of the two remote interior angles, which are angles 2 and 3. So in simple terms, M1 equals M2 plus M3. This property is important because it connects the exterior angles directly to the interior angles, and it's a key tool in solving many geometric problems involving triangles. Remember, this relationship applies to all triangles, and understanding it helps us see how the angles are interconnected, reinforcing the overall theme of triangle-angle relationships. Let's take a closer look at the inequality property of a triangle. This property is fundamental in understanding what makes a valid triangle. Essentially, it states that the sum of any two sides of a triangle must always be greater than the third side. For example, if we look at sides AB and BC, their combined length must be greater than the length of side AC. Similarly, if we add AB and AC, that sum needs to be greater than BC. And finally, adding AC and BC should be more than AB. These inequalities are key because they help us determine whether three lengths can actually form a triangle. If any of these conditions aren't met, the sides won't create a proper triangle. So, remembering this inequality property is crucial as we explore different types of triangles and their characteristics, ensuring that the sides we choose or analyze can indeed come together to form a valid shape. All right, now let's talk about the Pythagoras theorem of a triangle. When we have a right triangle, there's a special relationship between its sides. Specifically, the square of the longest side, which we call the hypotenuse, is equal to the sum of the squares of the other two sides. To put it simply, if we label the hypotenuse as AC and the other two sides as AB and BC, then the formula is AC, 2 equals AB 2 plus BC, 2. This can also be expressed as hypotenuse squared equals perpendicular squared plus base squared. This theorem is fundamental because it connects the lengths of the sides in a right triangle, and it's a key idea in understanding how triangles work. It also ties back to our overall theme of understanding geometric relationships and how they apply to real-world problems. Now, let's talk about congruence of triangles. When we say triangles are congruent, we mean they are exactly the same in shape and size. Think of it like fitting one triangle perfectly on top of another. If you do that, they would cover each other completely without any gaps or overlaps. This idea of congruence is fundamental because it tells us that the triangles have equal side lengths, equal angles, and equal areas. The symbol we use to indicate congruence is. So, when you see two triangles with this symbol between them, it means they are identical in all those key aspects. For two triangles to be truly congruent, all three sides and all three angles of one triangle must match exactly with those of the other triangle. Throughout this presentation, we'll explore the different tests or criteria that help us determine whether two triangles are congruent. These tests are crucial because they simplify the process of proving congruence without having to check every single measurement. Understanding congruence helps us see how different parts of geometric figures relate to each other, connecting back to the overall theme of understanding shapes and their properties. Let's take a look at case 1, where we have two triangles. The key point here is that if 3 sides of one triangle are exactly equal to 3 sides of another triangle, then these two triangles are congruent. This is known as the SSS, or side-side-side, criterion. It means that when all 3 corresponding sides are equal, the triangles are identical in shape and size. This concept is fundamental because it helps us determine congruence just by comparing side lengths, without needing to look at angles. It ties into our overall theme of understanding how triangles can be proven to be the same, which is essential in geometry problem solving. So remember, if you know all 3 sides are equal, you can confidently say the triangles are congruent using the SSS rule. Let's take a look at case 2. In this case, we know 2 sides and the included angle of one triangle are equal to 2 sides and the included angle of another triangle. This is what we call SAS, which stands for side angle side. The key idea here is that if 2 triangles have 2 sides and the included angle equal, then those triangles are actually congruent. This rule is quite powerful because it allows us to establish triangle congruence without needing to compare all sides or angles. Remember, the included angle is the angle between the 2 given sides. Connecting this to our overall theme, understanding SAS helps us recognize when 2 triangles are essentially the same shape and size, which is fundamental in solving many geometric problems. Let's take a look at case 3. This one involves having one side and 2 angles of one triangle equal to one side and 2 angles of another triangle. The key here is the ASA, or angle-side-angle, criterion. When 2 triangles have 2 angles and the included side equal, we can be confident that the triangles are congruent. This is because the 2 angles determine the shape, and the included side fixes the size of the triangle, ensuring complete congruence. Remember, ASA is one of the important criteria we use to establish triangle congruence beyond just side-side-side. Recognizing this pattern helps us understand the broader principles of geometric proof and reasoning. So, in essence, if you can match 2 angles and the included side, you've effectively proven the triangles are the same, which is fundamental in geometric proofs. All right, let's look at case 4. Here, we're comparing 2 triangles that both have a right angle, the hypotenuse, and one other side. The key idea is that if these 2 triangles share these 3 elements, then they are congruent by the RHS, or right angle, hypotenuse, side, criterion. This is a very powerful concept because it allows us to establish the equality of triangles quickly when these specific parts match. Remember, the RHS criterion is especially useful when dealing with right triangles, as it simplifies the process of proving congruence without needing to compare all sides and angles. So, in this case, recognizing the shared right angle, hypotenuse, and the other side helps us confirm that these triangles are indeed congruent, tying back to our overall theme of triangle congruence criteria. Let's talk about the area of a triangle. To find the area, we need to understand what the height actually is. The height, also called the altitude, is the perpendicular distance from the vertex opposite the base down to the base itself. It's crucial that this distance is measured at a right angle to the base. Once we have that height, the formula is straightforward. The area equals 1/2 times the height times the base. Remember, this formula highlights how both the base and the height are essential in calculating the area, emphasizing the geometric relationship within the triangle. Understanding this concept ties into our overall theme of mastering different methods to calculate areas. Heron's area formula. This is a really interesting and useful way to find the area of a triangle when you know the lengths of all 3 sides. It's named after Hero of Alexandria, an ancient Greek mathematician. The formula allows us to calculate the area without needing to know the height or angles, which can be very handy in many situations. The key idea is to first find what's called the semiperimeter. So, you add up all 3 sides and then divide by 2. Once we have that semiperimeter, which we call C, we plug it into the formula. the square root of s times s minus each side. So the area equals the square root of s times s minus a times s minus b times s minus c. This formula is powerful because it connects the sides directly to the area, making calculations straightforward once you have the side lengths. And remember, this fits into our overall theme of understanding different methods for calculating areas. It's a great example of how geometry can provide elegant solutions. And that brings us to the end. Thank you all so much for your time and attention today. I truly appreciate your engagement and interest throughout this presentation. Remember, the key points we've discussed highlight the importance of understanding the core concepts and how they connect to the bigger picture. I hope you found this session valuable and that it inspires new ideas and approaches in your own work. Once again, thank you all for being here. I look forward to seeing how you apply these insights moving forward.